In today's class, I will discuss boiling point, freezing point, and osmotic pressure. Like vapor pressure, these three are also the colligative properties of a solvent. What is boiling point? We discussed in our last videos. In short, it is the particular temperature at which the vapor pressure of the liquid will be equal to 1 atmospheric pressure, 1 atm pressure. This is called boiling point. Like boiling point of water is 100 degrees centigrade at 1 atm pressure or 1.003 bar pressure. Let's consider a pure solvent like water. Its boiling point is 100 degrees centigrade at 1 atm pressure. Now if you add some soluble solids like sodium chloride, sucrose, sugar, whatever may be, there will be elevation of boiling point. This is called colligative property. So we can say elevation of boiling point is the colligative property of water. How does it happen? See, boiling point is the particular temperature at which the vapor pressure will be equal to 1 atm pressure. So if you add some solutes, obviously surface solvent molecule will be mixed with solid molecule. So there will be some mixing of solid molecule causing number of solvent molecule will be vaporized is less. So temperature is there 100 degrees centigrade, but still sufficient vapor pressure is not there to make it 1 atm, because there is a drop in vapor pressure. To counteract this, you have to elevate the temperature a little more so that it becomes 1 atm pressure, and that is why there is an elevation of boiling point if you add amount of solutes in the solvent. See the board. T0 is the pure boiling point of the solvent, and T1 is the boiling point of the solution once you add some amount of solute into the solvent, and this difference is known as delta TB, or difference in the boiling point. This delta TB is equal to Kb into molality. Now what is Kb? It is boiling point elevation constant. Okay, this Kb is called ebullioscopic constant or boiling point elevation constant. This TB, delta TB, elevation in boiling point, is equal to Kb into molality. Now what is molality? Molality of what? Molality of the solute. Molality of the solute, correct? Okay. Now follow the board. W2 amount of solute is added to W1 amount of solvent, both in gram, and then the relation is delta TB is equal to Kb, ebullioscopic constant, into 1000 into W2, weight of solute, divided by W1, that is the weight of solvent, into molecular weight of solute. So this formula we can use to estimate the molecular weight of some unknown solute which is soluble in water or solvent like that. If we know delta TB, if we know Kb, if we know W2, W1, by relation we can easily calculate out molecular weight of the solute. This way we can calculate molecular weight of some unknown solute by using this formula. Now follow this formula. Kb is equal to R, capital R, into M1 into T1 square divided by 1000 into delta vaporization H. What does it mean? So we can calculate in laboratory also, in laboratory, the Kb constant for any liquid. What is that? R is the gas constant value. M1 is the molecular weight of the solvent. T1 square, T1 is the boiling point, pure solvent boiling point, divided by 1000 into change in the heat of vaporization. So if we know all these factors, we can conclude the value of Kb in. So we can use the value of a boiling point elevation. We can estimate molecular weight of solute, unknown solute, and this boiling point elevation is a colligative property of the solvent. Like boiling point, there is a depression in the freezing point when you add certain solute into a solvent. What does it mean? It means, say, pure water freezes at 0 degree centigrade under 1 atm pressure. If you add little bit of solute in it, the freezing point will be down to few fraction of degrees. This is called depression of freezing point while you add some solute into a solvent. This concept is used by adding little bit of glycol into pure water, where the pure water freezing point is 0 degree centigrade, but this solution on this mixture freezes at almost -5 degrees centigrade or something like that. So by adding some solute into a pure solvent, the freezing point of the solvent is reduced. Like normal freezing point of water is 0 degree centigrade, but if we use glycol or if we mix glycol to it, it reduces little less than 0 degree centigrade. It prevents normal freezing. This is called depression of freezing point. This is also a colligative property of the solvent. Now let us understand what is known as freezing point. It is the particular temperature at which the vapor pressure in the solid phase be equal to vapor pressure in the liquid phase. In this transition, liquid solidified or liquid becomes solid, liquid water becomes solid ice, and here the vapor pressure of the solid ice is equal to vapor pressure in the liquid. When it is equal, then obviously we known as this is freezing point, or we call it freezing point. For water it is 0 degree centigrade. When we add some solute into solvent, there is already a reduction in the vapor pressure. So now the liquid phase has lowered vapor pressure. Obviously, to be equal, solid phase will also have lower vapor pressure, and automatically there will be a reduction in the temperature, and that is called depression of freezing point. The water will freeze less than 0 degree centigrade, which freezes at normal point. Now follow the code. Delta Tf is equal to Kf into 1000 into W2 by M2 into W1. What does it mean? When you add W2 grams of solutes into W1, then there will be a depression in the freezing point equal to delta TF, and this is related by Kf. What is Kf? Kf is the cryogenic constant. Now, what does it mean? That means if you add W2 solute into W1, then the freezing point of water, then the freezing point of water will be down to 0 minus delta TF. Clear? So there will be a depression in the freezing point. What is Kf? Kf is called the cryogenic constant, and the value of cryogenic constant delta TF is equal to, Kf is equal to, it is universal gas constant into M1 into TF square. That's the normal freezing point of the solvent to the proportion 1000 delta fusion heat or delta heat of fusion. So these are the relation between the Kf and the risk factors. So now we can conclude boiling point elevation and freezing point depression both are colligative property of solvent, and these property depend on the molarity of the solute. So this is in general molarity of the solute in a solvent will decide how much elevation will be there in boiling point and how much depression will be there in freezing point. Another colligative property is osmotic pressure. To understand osmotic pressure, let us explain what is osmotic pressure. For this, we have to understand certain types of membrane called semi-permeable membrane. These types of membrane usually allows the liquid portion to pass through it, but not the solid one. Now say you are designed a two chamber. There is a two chamber and you put a semi-permeable membrane just in the middle. In one chamber you put water and in another chamber you put water mixed with sugar. Now the chamber that contains the solute will exert little more pressure on the permeable membrane than the pure liquid one, because the solute will try to move from the higher concentration in the solution to the lower concentration in the pure liquid, but it will not be allowed. So it will create some pressure on the permeable membrane. This is known as osmotic pressure. This is called osmotic pressure. The pressure that is created on the semi-permeable membrane to make both the liquid with same concentration. In solution state, there is higher concentration of the solute. It will try to move to the lower concentration pure solvent. As a result, they will exert certain pressure on the semi-permeable membrane, and semi-permeable membrane will not allow them to move through. This is called osmotic pressure. Now we follow the board. Osmotic pressure is denoted by pi. This pi is equal to C RT. Now what is C? C is a concentration. Concentration in what form? Number of molecules, number of moles in per volume. So that is N by V. R is the universal gas constant. T is the temperature, because this osmotic pressure usually depends on temperature. Higher the temperature, higher is the pressure. Higher the mole concentration, higher is the pressure. And gas constant is R, is a constant. So naturally we can say from this equation the osmotic pressure of a solution depends directly with the molarity of the solute in the solution. Pi is equal to N by V RT, where N is the number of solute, number of moles of solute. So herefrom I can get pi V is equal to W2 by M2 RT. W2 is the weight of solute, M2 is the molecular weight, R is the Gauss constant, T is the temperature. So we can say M2 molecular weight of this unknown solute should be equal to weight of the solute into R into T to the proportion pi into V. So we can conclude osmotic pressure is a colligative property because number of solute will decide what should be its osmotic pressure. So in the solution chapter, so far we have studied 4 colligative properties, that is vapor pressure, boiling point, freezing point and osmotic pressure. If you have any question, any comments, please let me know that we can discuss it. Thank you very much.